Hi, I'm RL from MathinSG.com. In this video here, I'll be going through the H2 A-Level Math 2024 paper 1, question 7. So this is the full work solution for the 2024 H2 A-Level paper. So if you're interested, you can download it here. I also provide the link to this website in the description below. So let's go through this question. So this question is basically a trigo question, some sort of trigo manipulation question, as well as a sequence and series question, because the part of sequence and series that's being tested here is actually method of difference. It is no longer in your syllabus. Even the trigo manipulation portion here, you can also skip, because this one requires you to use the factor formula, which is here, and this is from your MF 26, which is the previous data booklet, and this is from MF 27, the math formula booklet that is used from 2025 onwards for the revised H2 A-Level math syllabus. I actually talk quite a lot in this this blog post here, so you can read through if you are interested. But if you basically just want to try or prepare for your A-levels, H2 A-Level math, you can skip this question. Alternatively, I've modified this question so that it is in your syllabus, which is here. So if you are interested, this is the modified version of question 7, which can come out in the A-Level syllabus. So let's try this question now. Okay, let's go through this question. This is the modified version of question 7 from 2024 paper 1 H2 math. So if you have to look at this, we are given the summation of sine 2r theta is equals to this, and you're asked to find 3 possible values of this. So how is this related to this one here? Well, recall, if you have sine 2a, you'll get 2 sine a cosine a, right? So this one looks like this portion here without the 2 in front. So I'll give this part half. So now I'm going to copy this right below it. So I have sine pi r over 6 cosine pi r over 6. So it seems like my a is pi r over 6, right? Okay, so this portion, I'm going to change it to this portion, and this portion looks like this portion, and I can make use of this result here. So let's do it. Okay, so I'm going to change this to half, put it outside since it's a constant, sine 2 pi r over 6. And if you have to compare this portion here with this portion here, there is a 2 here, which is here, there's an r here. So basically my theta is pi over 6. So what I'm going to do is I'm going to sub pi over 6 into this one here. Okay, so they ask for 3 possible values, right? So cosine pi over 6 is a fixed value. 2 sine pi over 6 is also a fixed value. The one that can give the 3 possible values come from here. Alright, so let's do it. So I first put in cosine pi over 6 is essentially root 3 over 2. Right? Then 2 sine pi over 6 is sine pi over 6 is half. Okay, so this is 2 times half. Okay, then I have cosine 2n plus 1 pi over 6. So if I were to simplify, this one is basically just 1. So I have half times root 3 over 2 is root 3 over 4 minus half cosine 2n plus 1 pi over 6. Okay, so the one that will give 3 possible values is this portion here. So recall that cosine is a cyclical function, right? Something like this. Okay, so after a while the values will repeat. So we know that because this is a summation question and is an integer, and it must be a positive integer that is greater than or equals to 1 based on this notation here. So we know that when we sub in n equals to 1, 2, 3, 4, 5, 6, 7, 8, and so on, after a while, the values of cosine 2n plus 1 pi over 6 will start to repeat itself because of the nature of a trigo graph. Okay, it is a periodical graph. So after a while, the values will repeat itself. Okay, so what we can do is you can actually type it into your GC. You can type in y equals to cosine 2n plus 1 pi over 6. Okay, then you see what are the values that it gives. But take note, this one, the GC will give you decimals because there's some root 3 in some of the values. Okay, some of the values will be decimals. So you do need to know the special values for cosine, sine, and tangent for pi over 6, pi over 4, pi over 2, okay, and pi over 3. Okay, these are the special values. Okay, and you also need to know when they are in other quadrants. All right. Okay, so now coming back to this one here. So let's first just take a look at this one. So what I'll do is I will first type into my GC this. Okay, root 3 or maybe not root 3 over 4. I'll just type in this one. Then you realize that it basically just takes 3 values. Okay, after a while, then you then go to the table. You'll see that it takes basically just these few values. Okay, it's just 3 values because they say 3 possible values. Okay, but never mind. But some of them are in decimal, so you do need to know what is the exact value. Okay, just put it into your calculator, square. You know that trigo, if it's you want exact value, right? And they give you decimal, you square it, then you know that the answer is the square root of it. Okay, but never mind. Let's first go through this. So I know that n can take various values, right? Like 1, 2, 3, 4, 5. Cosine 2n plus 1 pi over 6. Okay, so I know that when I put in n equals to 1, I have cosine pi over 2, right? Which is 0. Correct? Then next, when I put in this one, I'll get cosine. When n equals to 2, I have cosine 5 pi over 6, which will give me negative root 3 over 2. Similarly, if I were to put in when n equals to 3, I have cosine 7 pi over 6, which again gives me negative root 3 over 2. Right? Then when I put in 4, is cosine 9 pi over 6, which is cosine 3 pi over 2. Is again 0. Okay, I only have 2 values now, so let's continue until I reach the third value. So I have cosine, when I start in n equals to 5, I have cosine 11 pi over 6. Okay, and this will give me positive root 3 over 2. Okay, then if I were to repeat this, you'll notice the pattern starts to repeat. Basically use your GC, okay? But you just need to know that the decimals, what values do they correspond to if you want exact value. Okay, then this one is 13 pi over 6 then. So it is root 3 over 2 again. Then you put in 7, so it's cosine 15 pi over 6. Okay, which is 5 over 2. So this is back to 0, right? Then you notice that when you put in 8, okay, so minus 2 pi 12, 5, which is the same as this again. And so on. You notice that the pattern starts to repeat. So it'll be 0 minus root 3 over 2, blah, 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 blah. So you know that this takes 3 values, right? So this cosine 2n plus 1 pi over 6 takes 3 values. It takes either 0, minus root 3 over 2, or root 3 over 2. So the 3 values are this, or Okay, so the three values are root 3 over 4, okay, or this one here, this minus root 3 over plus, so this is root 3 over 2, okay, or this is the same, right? Root 3 over 4 minus root 3 over 4, which is 0. So these are the three possible values, root 3 over 4, root 3 over 2, or 0.